This is the map of electrical engineering. I made it to take you on a journey with me. A journey going from an average guy to an average guy with a degree in electrical engineering. So let's step into it. We start a journey in the electronic city, where you learn about circuit analysis. Here you have to pay attention to two things: voltage and current. Voltage is the difference in potential between 2 points. I've shown the potential as a color. Current is the flow of charge, which I've shown as cars passing by. The relation between them is that when there is a voltage, there will be a current. The higher the voltage, the higher the current. When analyzing these things, you learn about two laws to calculate them: Kirchhoff's voltage law and Kirchhoff's current law. You also have 5 basic components to control the voltage and the current. Voltage sources to control the voltage, current source to control the current, resistors to lower or higher the current, inductors to slow down changes in current, and capacitors to slow down changes in voltage. And you'll be surprised by how much you can do with just these components, but you can do even better, which brings us to the next city, the electrical engineering city. In our digital design class, you'll learn that everything is either high or low, 0 or 1. To control these values, use one of the most important devices you'll find here, the transistor. We use transistors to create logic gates. With logic gates, we can compare multiple 0-1 values at once. Using logic gates, we can then create combinational circuits, with which we can basically create any operation. We can even make circuits to remember by making latches and flip-flops. Your task in this class is to combine these tools to create useful machines. As we get more comfortable with these tools, we can move on to the next class about computer architecture. All of our previous tools now come together to understand the invention that changed the world, the computer. You learn about things like CPUs, I/O systems, RAM, and how they are all connected. Now we're getting a bit too close to the world of computer science, so let's go to the next city on our map, the instrumentation city. Here we can finally incorporate the outside world into our devices. Use special devices like thermometers, pressure gauges, and so on to turn them into electrical signals. These signals alone are already fantastic, and we can make them even better by adding some added tweaks, which brings us to the next city, the signal processing city. On your journey, you will find that one of the best signals that you can possibly have is a sinusoid. But most signals aren't sinusoids. There's a trick, a Fourier trick, which lets us break up any signal into sinusoids. So, how do we actually use the signal? Welcome to the systems and control city. Here we use the signal that we have to get the behavior that we want from our device. We even use feedback to figure out what we're doing wrong or right. Feedback is when we put our output back into our input. And now for the fun part. We can even change the signal that we have. In your signal processing class, you learn about amplifying, removing noise, compressing, and modulating your signal. Let's take a step back now. You already know a lot about learning how to make stuff, so pat yourself on the back. But how does any of this actually work? Welcome to the strange land of electricity and magnetism, where you learn about what voltage and current really are. You even learn about some scary equations called Maxwell's equations. And now for the magical part. You learn about light, which you can only really appreciate in your wireless communications class. Here we use light to talk with other devices. You learn about weird stuff like Wi-Fi and Bluetooth and how it actually works. It gets even crazier when you learn that light can diffract, reflect, refract, and more. You even understand weird devices like microwaves and lasers. The end is almost in sight. As the final part of electrical engineering, we look at the source of all of this power we got so far. In your electrical power conversion class, you learn how to convert power from one form to another. You also learn about how things like this actually affect our daily life, when learning about power systems and much more. Congratulations! You know the material any electrical engineer needs to know if they want to get a degree. But we do have to address the bedrock of it all, mathematics. Maths is the language you're going to be speaking as an electrical engineer, so get accustomed to it. So now you know everything you'll learn. Are you ready to start?